to look at the GCSE required practical that asks you to investigate resistors in series and parallel. So this is the equipment we're going to use. Have a think about how you will do that now. So in order to do this practical, we first need to recap how we measure resistance of any component. So we're going to start with a really simple circuit. We're going to start with a single resistor, an ammeter and a voltmeter, and a cell, just to recap how we work out resistance. So in order to do that, I'm going to connect firstly the ammeter and the resistor in series. So I'm going to make a single loop with the ammeter and the resistor, check that it's working. And then I'm going to add the voltmeter in parallel. So I'm going to make a second loop across the thing that I'm measuring. So in this case, the resistor, one wire goes into each side of the resistor. Turn that on and check it's working. Now you might get a minus sign. So if you get a minus sign, it just means we're measuring current in the opposite direction, or potential difference in the opposite direction. If it's just one of the meters, you can just switch the connections around. If it's both of them, the quickest way is probably to just reverse the connections on the power pack. So switch positive and negative, and now we see they're both positive. You can just ignore the minus signs, but it is obviously nice to get them positive. So now what we can do is we can write down what the current is. So current in this case is 0.06 amps. We can write down what the potential difference is. So I've got 0.6 volts. And then I can work out resistance. Resistance is the potential difference divided by the current, which is 0.6 over 0.06, which is 10 ohms. So obviously that is the case because this is a 10 ohm resistor, but this is a recap of how we would actually do it in a circuit. So now what we're going to do is investigate resistors in series and parallel. So these are the two circuits we're going to start with, and I'll show you how to set these up, and then I'll give you a few more examples. So two resistors in series, how does the resistance compare compared to those same two resistors in parallel? You can use any value resistors you want. Obviously, whatever value resistors use here, you're going to also use over here. In my first example, I've got a 10 and a 20 ohm resistor. So in order to do this, I'm going to unplug pretty much everything and start again. If you try and put things in without really doing it logically, you can easily get confused. So I'm going to put my resistors side by side, and again I'm going to start by making one loop with all of them in. And if I do it this way, then it's really clear what I'm doing, and I can really avoid making any mistakes. So here I've got one loop with everything in. And again, a little bit of wiggling, just make sure we are actually getting current. And then I want to measure the potential difference. Now I've got to be really careful when I do this. If I put the potential difference just across one resistor, I'm not measuring the entire potential difference. So I need to make sure, just like in the circuit diagram, that I measure the potential difference across the entire resistor combination. So in this case, I need to go from the start of the first resistor to the end of the second resistor. I can then do exactly the same as I did before. I can note down the current, I can note down the potential difference, and I can work out the resistance of the resistors in series. I then want to compare that to them in parallel. So again, I'm going to unplug pretty much everything so that it's nice and clear. I'm going to put them in a slightly different combination this way. I'm going to put them one on top of the other so that I can very clearly make some separate loops. And I'm going to use different color wires so that I can check very clearly that I've put them in separate loops. So I'm going to make a new loop on top of the black wires for my 10 ohm resistor. You can see it is a new loop, and then I'm going to get my voltmeter and I'm going to measure from the start of the first resistor to the end of the same first resistor. Because they're in parallel, the potential difference across the two loops are the same, so I could do it across this one as well. So now I can do exactly the same. I can note down the current, I can note down the potential difference, and then I can use my formula resistance. It is voltage or potential difference divided by current to work out the resistance of the resistors in parallel, and then I can compare that to my first circuit. So in my exercise book, I will draw out the circuits, I will write down my current reading, write down my potential difference, write down how I'm going to work out resistance, and then write it down. And I can compare it to the same one in parallel. And you can see here I've actually labelled my resistors with the values. So now what you can also do to go a bit further is you can add a third resistor. So I have 100 ohm here. You can use whatever value you want. You can compare how 3 resistors in series compares to 2. And then you can see how 3 resistors in parallel compare to those in series, and also the 2 in parallel. And then there's one more that you might want to try. What happens if you put 1 in series with 2 in parallel? This one is a little bit tricky to make, but if you do it logically, one at a time, different color wires for each loop, you'll be able to do this. And again, you can see how this compares to 3 resistors in series or in parallel. And you can maybe make some predictions as to whether you think this will be more than 10.